Good morning students, welcome back. So in the previous class we have studied about the algorithm, that is Hungarian method algorithms. There are 9 steps in Hungarian method algorithm. So in this session we are going to solve the problems, that is assignment problem by using Hungarian method. Fine. So I have told you, we have understood that the 50% of the algorithm. As a students, you understood the 50% of the algorithm. Remaining 50%, it is little bit difficult to understand, but when we start solving the problem, we will understand the algorithm 100%. Fine. I am sure about it. So let us start solving the problem. That is the first problem. That is example number 1 here. 1. Using the following cost matrix determine a optimal job assignment followed by cost of assignments. Cost of assignments. So here it is 1, 2, 3, 4, 5, followed by A, B, C, D, E. Right? So these are the values here. It is 10, 3, 3, 2, 8, for 9, 7, 8, 9, 7, 8, 2, 7, 7, 5, 6, 2, 4, followed by 3, 5, 8, 2, 4. And it is 9, 10, 9, 6, 10. Fine. So as per the algorithm, that is Hungarian algorithm, first step, the given assignment problem has to be a square matrix. Fine. So let us see whether it is a square matrix or not. What do you mean by square matrix? Number of rows should be equal to the number of columns. That is called as square matrix. So 1, 2, 3, 4, 1, 2, 3, 4, 5. So 5 rows and 5 columns means the transportation problem is, the assignment problem is balanced. Fine. Solution. Let us go for the solution. Select the smallest element in each row and subtract this element from all the elements in the same row. Fine. So what happens here if you are supposed to do it? So this is, so let me put it in the matrix. Let me write this is A, B, C, D, so it is 10, 3, 3, 2, 8, it is 1, 2, 3, 4, let me write 5 here. Fine. So it is 10. What I am supposed to do here? Out of this row, first row, which is the minimum value. So 2 is the minimum. So this 2 has to be subtractable to all other elements in that particular row. So now first take this 10. So 10 minus 2 is how much? 8. Then 3 minus 2 is 1. 3 minus 2 is 1. 2 minus 2 is 0. 8 minus 2 is 6. So first row is finished. And what is the minimum value in second row? That is 2 here. This is the minimum value. So 9 minus 2 is 7. 7 minus 2 is 5. 8 minus 2 is 6. 2 minus 2 is 0. Again 7 minus 2 is 5. And what is the minimum value here? 2 in this third row. So 7 minus 2 is 5. 5 minus 2 is 3. 6 minus 2 is 4. 2 minus 2 is 0. 4 minus 2 is 2. So again, which is the minimum value in this fourth row here? 2. So 3 minus 2 is 1. 5 minus 2 is 3. 8 minus 2 is 6. 2 minus 2 is 0. 4 minus 2 is 2. And which is the minimum value in this last row, that is fifth row? 6. 9 minus 6 is 3. 10 minus 6 is 4. 9 minus 6 is 3. 6 minus 6 is 0. Again it is 4. Fine. So what happens here? This is what we have done with finding the minimum element in each row and subtracting that element from the elements of that same row. So we have to do the same thing with the column here. So subtract, so let me draw the line here. Subtract the minimum element from each column, with the elements of same column. Right? Subtract the minimum element from each column with elements of the same column. So let me do this one. So let us take the column here. So let me write the values. This is A, B, C, D, E. It is 1, 2, 3, 4, 5. Fine. So now what happens here? Which is the minimum element in this column? 1. So 1 minus, that is 8 minus 1 is 7. 7 minus 1 is 6. 5 minus 1 is 4. 1 minus 1 is 0. 3 minus 1 is 2. Fine. So again find the minimum element in this column, that is 1. That is 1 minus 1 is 0. So 5 minus 1 is 4. 3 minus 1 is 2. 3 minus 1 is again 2. 4 minus 1 is 3. Fine. So again find the minimum element in this column. So 1 is the minimum element. So let me put 0 here. 1 minus 1, 0. 6 minus 1 is 5. 4 minus 1 is 3. 6 minus 1 is again 5 here. So 3 minus 1 is again 2. Fine. So in this element, 0 is the minimum element. Subtract 0 minus 0 is 0, 0, 0 and 0 and 0. So in this final column, which is the minimum element, 2 is the minimum element. So it is 6 minus 2 is 4, followed by 5 minus 2 is 3, then followed by 2 minus 2 is 0, 2 minus 2 is 0, 4 minus 2 is 2. So this is what the matrix we got after row subtraction and column subtraction. So what next? So in this modified matrix, in this modified matrix, we draw minimum number of lines, vertical and horizontal, to cover all the zeros, So what we have to do here, we have to draw the minimum number of vertical and horizontal lines, fine, such that to cover all the zeros in the table. So let me again draw the table here. So this table is nothing but A, B, C, D, E. It is 1, 2, 3, 4, 5. Fine, it is 7, 0, 0, 0, 4. It is 6, 4, 5, 0, 3. It is 4, 2, 3, 0, 0. So it is 0, 2, 5, 0, 0. So it is 2, 3, 2, 0, 2. Let me check whether I have written the values correctly or not. It is 7004, 64503, 42300, 02500, 230. So we have to draw minimum number of horizontal and vertical lines to cover all the zeros. So here I go with the maximum number of zeros are here. So I draw the line. Here the maximum number of zeros are here. So I draw the line. So the next comes here. The next comes here, where I go with, here are the two zeros here. Here are the maximum 2 zeros, and here also maximum 2 zeros. Fine. So the remaining with this zero. So let me draw here. Fine. So all the zeros are covered. Fine. So the number of drawn. So the drawing of lines, horizontal and vertical lines, you have to practice it. So you can draw 1, 2, 3, 4, 5, 6. How many lines? Maximum lines you can draw, but we have to draw minimum lines to cover all the zeros. Fine. So the maximum number of lines drawn to cover all zeros is 4, that is equal to n, and order of matrix is what? 5, that is equal to n. Hence what happened here? n is not equal to n. That is, n is less than n. So in that case, you are supposed to go for the next step. So now we get second modified matrix by subtracting the smallest uncovered element from the remaining uncovered elements. Fine. So what to do? We have to get the second modified matrix. Once capital N is less than n, we have to go for the second modified matrix. So how to get the second modified matrix? Choose the smallest element which is uncovered by the lines, horizontal or vertical lines, which is uncovered by the lines, and subtract that smallest element from the remaining uncovered elements. Fine. And adding it to the elements at the intersection of lines. So not only finding the smallest uncovered element and subtracting with the remaining uncovered elements, we have to add that smallest uncovered element at the intersection of the lines. Fine. Here it is intersection, here it is intersection, here it is intersection. We have to add that smallest element to the respective cost. So to do this, again, it is A, B, C, D, and it is E. So let me write 1, 2, 3, 4, and 5. So, which is the smallest element here? There are smallest element is 2, 2, 2. So 2 is the smallest element. So let me take 2 as the smallest element. So I will add here at the intersection of the line. So 7 plus 2 is how much here? 9. Remaining I will keep as it is 0, 0. Here the intersection comes here. So 0 plus 2 is 2, followed by here also intersection comes 4 plus 2 is 6. Fine. So remaining 6, 4, 0, 2. So let me write 0, 0, 0, 0. So it is 3 followed by 0, 0 and 2 here. So I have to subtract this minimum uncovered element with the other uncovered elements in that cost matrix. So 4 minus 2 is how much? So it is 2 here. 5 minus 2 is 3. 2 minus 2 is 0. 3 minus 2 is 1. 2 minus 2 is 0. 5 minus 2 is 3 here. Followed by 3 minus 2 is 1. So 2 minus 2 is 0. Fine. So what happens here? Again we draw the number of horizontal, minimum number of horizontal and vertical lines to cover all the zeros. Once again I will tell, again once we got the second modified matrix, we have to draw minimum number of horizontal and vertical lines to cover all the zeros. So So here maximum 4 zeros are here, so I will draw a line. Fine. So here there are 3 zeros, so I will draw the line. Here there are 2 zeros, I will draw the line. Here also there are 2 zeros, I will draw the line. So remaining is 1, so I will draw the line. So I have drawn all the lines. Now what happens? We have to check how many number of horizontal or vertical lines we have drawn. Minimum number of horizontal and vertical lines we have drawn to cover all the zeros. So here what happens? Number of lines is equal to drawn to cover all the zeros. That is equal to how much? Capital N is equal to how many lines we have drawn? 5. 1, 2, 3, 4 and 5. So order of the matrix is equal to 5. So capital N is equal to small n, that is 5 is equal to 5. Fine. So now we determine what happens. Now we determine the optimum assignment. Now we determine the optimum assignment. Here job followed by mechanic and followed by cost. So now what happens here? Check out how many zeros are here. So this is the only zero which we have, so I will allocate. And here I have 3 zeros here. Make sure that the allocation, so here I will do the allocation here. Fine. When coming to this one, if I allocate here, no other zeros can be allocated in that same row and in that same column. Fine. So these are the zeros I cannot allocate here. Fine. These are the zeros I cannot allocate. Fine. Now comes here. This is the only zero available. So let me put this here, and these zeros also cannot be allocated. Now comes what here? So I will put allocate here. So this zero cannot be allocated. So the remaining is this one. So this is you will learn by practicing. Fine. So when I square a circle here, the zeros in that respective column cannot be allocated, and in the row the zeros cannot be allocated. What I do here, when I circle it, I cross off the other zeros in that same row and that same column. So here it is, I have squared this zero here, so the remaining zeros in that row will be crossed. Fine. So here I have done here. So once this is crossed, this second column row, second column zero is crossed here. So the only remaining is that what? This one or this one. So what I do here, I will choose with this one. So this will also get crossed. So now coming to this one, if I square this one, this zero is also what? Crossed. So coming to this one here is the only one remaining in this row and in this column. So I have squared here, so remaining is crossed. So coming to the next is the only remaining, because this is also crossed. So I will choose this one. Next, this one. So let me do the job assignment. That is 1, 2, 3, 4, followed by 5. So mechanic 1. So 1 is corresponds to D here. So 1 is corresponds to D, whereas 2 corresponds to A. So 2 corresponds to A, 3 corresponds to E, then 4 corresponds to B, then 5 corresponds to C. Fine. So what is the value of original value of D? So original value of D, that is, let me say this, let me write original value of this. So let me mark. So this is what 2. Original value is, this is what I will mark. Then followed by 2A, that is here, that is, sorry, this is 3. I will mark, followed by what happens? Followed by 3. Here it is. Then followed by this one, I mean to say this one, then followed by this one, and the last is this one. So these are the allocations. Let me write the original cost. It is 3, followed by 3, followed by 9, then followed by 2, then followed by 4. So addition of all these things, addition, that is rupees 21. So what I supposed to write here? Minimum cost rupees 21. So we got the minimum cost of this assignment problem. So let me repeat the same problem once again for more clarity. Fine. So this is what the given problem. So this is called as cost matrix, and we have to determine optimal job assignments and the cost of assignment. This is what the optimal job assignment, and it is called cost. Fine. So the given cost matrix is written in this format. Fine. So we have to choose what? Select the smallest element in each row and subtract that smallest element from that particular row. Fine. So do this for all the rows in that cost matrix. So this is what I am doing here. So I got the cost matrix, that is what? Row subtraction. I will say this row subtraction. Once we got this matrix, go for the column subtraction. The column subtraction is like subtract the minimum element. Fine. Subtract the or select the smallest element from each column and subtract that element from the other elements of that respective column, and do repeat this with all the columns. So when we do this, we got the first modified matrix. So in this modified matrix, we have to draw minimum number of horizontal and vertical lines so as to cover all the zeros. Fine. So this will come by the experience. As you solve more number of problems, you will learn how to draw the minimum number of horizontal and vertical lines to cover all the zeros. So the number of lines are drawn called as capital N. So here, once we draw all the lines, we have to check how many lines we have drawn. That is capital N. So in this case, we have drawn 4 lines. That is N is capital N is equal to 4, and it should be equal to the order of the matrix. Then only we can say we got the optimal assignment. Once again, I will repeat. If the minimum number of horizontal and vertical lines drawn are equal to the order of the matrix, then we can say the optimal assignment, and we can start assigning. But in this case, here order of the matrix is greater than the number of lines, means the number of lines drawn is less than the order of the matrix. Then we go for the second modified matrix. From first modified matrix to second modified matrix. So in this, there are 2 types here. First modified matrix, then second modified matrix. First modified matrix is obtained by subtraction, that is row subtraction, that is selecting a minimum element from the row and subtracting that minimum element in that particular respective row. So do this for all the rows. Then same thing, you select a minimum element in each column and subtract that element from the other element in the respective column, and do this for all the columns. Fine. Then we get the second modified matrix. So then we get first modified matrix. So in the first modified matrix, we have to draw minimum number of horizontal and vertical lines to cover all the zeros. If the number of lines drawn is equal to the order of the matrix, we say we can do optimal assignment. If the number of lines drawn is less than the order of the matrix, then we go for the second modified matrix. So in second modified matrix, what we do, so we have to choose the minimum uncovered element. We have to choose the minimum number which is uncovered here. So choosing that uncovered or selecting that uncovered element from the first modified matrix, we have to subtract that minimum element with other uncovered elements of the first modified matrix. Not only subtracting, adding that minimum element wherever the intersection of the horizontal and vertical lines happen. So in this case, here, here and here, in three places the intersection is happening, and this is what the minimum element 2. So you have to add in this location, in this location and in this location. Where the lines are there, we have to keep the value as it is, whereas wherever there is an uncovered element, means wherever there are no lines, we have to subtract that minimum element. Fine. Once we do that, we will get the second modified matrix. Once we get the second modified matrix, again we have to draw the minimum number of vertical and horizontal lines to cover all the zeros here. So we have to draw. So we have drawn here in this case. So in this case, there are 5 horizontal or vertical lines to cover, minimum horizontal and vertical lines to cover all the zeros. So the number of lines drawn to cover all the zeros here in this case is 5 after second modified matrix. So the order of the matrix is 5. Now comes the order of the matrix and the minimum number of lines are same. Here we can go for optimal assignment. So in optimal assignment, what we do, now we determine the optimal assignment. So this is how we are supposed to write job, mechanic and cost. So jobs are 1, 2, 3, 4 here. Here jobs are 1, 2, 3, 4, and the mechanic is like in this case how we are supposed to do the assignment. Here square the circle and make sure that the circle and that particular row and in that particular column is crossed off, so that no future assignments done in that particular row and in that particular column. So now this is done. Come here, this circle is, you cannot do the assignment here, so this circle is available, but I will go with this circle. So remaining these 2 circles are also crossed off, and also the respective row, in this respective row, this circle also is crossed. Now coming to this, I will make an assignment here in this column, that is the respective row is also crossed off. Now come here, now come to the next one, I will choose this one, so that this and this 0 is also crossed off. Now the remaining is only this one, I will make an assignment. So what happens here? So job 1 mechanic D will do, job 2 mechanic A will do, job 3 mechanic E will do, job 4 mechanic B will do, job 5 mechanic C will do. And what is the original cost? The original cost here 3, 9, 2, 4. Addition of all those costs will give you rupees 21. So this is what the minimum cost. Fine. So this is what the first problem. That's why I have taken so long time to explain it twice, so that you can understand it. Thank you. Thank you very much.